And here, so this is question 1 for the final exam review, right? This is for our final exam. We already took our midterm. And here it says, we want to find the vertex and the axis of symmetry. Our function here, they call it g of x. I don't care. I'm calling it f of x equals -2 times x minus 2 squared plus 2. Okay. So since this problem is set up as in standard, is this what we call standard form? It's set up in vertex form. Our vertex is going to start out at the point 0, 0. But because of the transformations, this -2 is a transformation and it belongs with the x because it's on the inside, right? If it's on the inside of the parentheses, if it's on the inside of the function, it belongs with the x. And if it belongs to the x, it does the opposite of what we want, and it does that horizontally. So we really want -2 to go to the left 2, but it doesn't. -2 goes to the right 2. All right, and then our other problem here, or sorry, the other transformation is this +2, and this +2 is on the outside. If it's on the outside of the function or outside of the parentheses, it belongs with the y, and it does the same, and it does that vertically. So we really want a +2 to go to the up, to go up 2. And if it belongs to the y, it does. So our vertex here, we are going to add 2 to our x's and add 2 to our y's. The vertex is the point 2, 2. And what's really nice is it will tell you how it wants you to write your answer. You want to write your answer as 2, 2, because that's an ordered pair. All right, I'm going to pause. All right, so we got our vertex. To get the axis of symmetry, it's the axis of symmetry, you have to type it as an equation. The axis of symmetry will always be x equals the x value of the vertex. So it's always the first part of the ordered pair, but you have to write it as x equals 2. So you just got to make sure you're writing it as x equals 2. And then they want to know, is the graph concave up or concave down? And so here, the number out in front, if the number is positive, it's concave up. If that number is negative, it is concave down. So in this example, it's going to be concave down. Okay. Now, when it says use the graphing tool to graph the function, in my math lab, what it comes up with is it comes up with the transformation tool. So with the transformation tool, it will give you, is it a line? Is it a parabola? Is it an exponential, or is it a logarithm? It'll give you that. You want to make sure that you select the tool that says quadratic, okay? And then you can put your cursor anywhere you want, because after you put your cursor anywhere up, it comes up with a box with the shifts. So it comes up with a box and it'll say like horizontal shift. It'll say horizontal shift, vertical shift. And so the thing that you want to put in first, that this thing is reflected about the x-axis. So here, we didn't talk about what this -2 does. That -2 is on the outside. So it belongs to the y. If it belongs to the y, it does the same. It does what we want, and it's in the vertical direction. But this is really broken up into 2 things. It is a vertical reflection. It's a vertical reflection. A vertical reflection, and if you're thinking about a vertical reflection takes the stuff that's above and puts it below, which actually is a movement over the x-axis. So this is an x-axis reflection. And the reason why we have to know it as that is because this is going to be a checkbox. We want to reflect it horizontally. Sorry, not horizontally. We want to reflect it with the horizontal axis, which is the vertical. It's a vertical reflection, but it's about the x-axis. anyway, we're going to say there's an x-axis reflection. Okay. I actually think that's the last box that we are going to select. Before we do that, we have to make sure to do order of operations. So the 2 here is a vertical stretch by 2. So we have a vertical stretch by 2. So in here, in that box where you're graphing it, but you're really not graphing it, you're just putting the information about the transformations, put the vertical stretch first, then you put your horizontal shift, which is by 2, it's 2 to the right, and then you put your vertical shift, which is up 2, and then the last thing you do is put in that it is vertically reflected. Another way to say a vertical reflection is about the x-axis. Okay, so you're not like picking 2 points on this problem. You're graphing using the transformation tool. Okay. All right, that covers everything about this problem. We said that this was down, and then we graph it. All right, let's pause here, see if there are questions. All right, I'm just going to write out all the transformations that we have here and the order that you have to put them. The first transformation is vertically stretched by 2. Then you have to put that it goes to the right 2, and then you have to put it goes up 2, and then you check the box that says x-axis reflection. Okay, then check that box, or there's a box and you'll check it. Okay, all right, let's pause here. There we go. Hopefully that clears up any. All right, so for the final exam review number 2, we have the function f of x equals x squared plus 2x, and we're going to answer a whole bunch of questions here about it. So the first one says, graph the quadratic function by determining whether the graph opens up or opens down. So here, to find out if it opens up or opens down, we can write out what A is. A is 1, B is 2, and C is 0. If A is positive, so if A is positive, it opens up. If A is negative, it opens down. Because RA is positive, our graph is going to open up. Okay, to find the vertex of the parabola, the vertex of the parabola is going to be x value of the vertex is equal to negative b over 2a. So in our case, we know what a, b, and c is. In our case, our x value of the vertex is equal to negative 2, because that's b, negative 2, divided by 2 times 1. That's going to be negative 2 divided by 2, which is negative 1. And then to find the y value of the vertex, it's really nice. You just plug 1 back into the function. So we call that f. And I said 1, but it's really negative 1, right? Plug in f of negative 1. That's going to be negative 1 squared plus 2 times negative 1. And negative 1 squared is negative 1 times negative 1, which is positive 1. So we get 1 plus, well, it'll be 1 minus 2, because 2 times negative 1 is negative 2. 1 minus 2 is negative 1. The x value of the vertex is negative 1, and the y value of the vertex is also negative 1. So that point is negative 1, negative 1. All right. The axis of symmetry. This is always your axis of symmetry. Your axis of symmetry is always x equals, so don't forget your x equals the x value of the vertex. It's x equals negative 1. All right, we're going to pause here just to see if there are questions, comments, concerns. All right, so now we're going to find the x-intercepts. We're going to find the x-intercepts, and x-intercepts happen when y equals 0. So we have our function up here, and I know things are getting a little bit messy and my organization isn't always the best, but there's our function. We're plugging in 0 for f of x. So 0 equals x squared plus 2x. We need to factor this. Well, both terms have an x, so it's going to factor to x times x plus 2. And then you set each factor equal to 0. So either x equals 0 or x plus 2 equals 0, subtract 2, you get x equals -2. All right. We have to be careful. They want us to type this. Oh, never mind. We do have to be careful, but I was looking at the wrong one here. Type as an integer or a decimal. They just want us to put 0 and -2 as the answers. So 0 and -2. That's how we're going to enter it. We are entering it as 0, -2. It's not as an ordered pair. MyMathLab is not consistent. Well, it is consistent, but it's annoyingly consistent. We probably should. That's fine. It doesn't matter. That's how you're entering it. What's the y-intercept? Well, the y-intercept happens when x equals 0, which is just f of 0. So we need to just go back, look at our function real quick. Our function is x squared, so that's going to be 0 squared plus 2 times 0. Well, f of 0 is just 0 because 0 squared is 0. 2 times 0 is 0. So and again, the way that they want us to do it. Okay, so first of all, we have to select, is there a y-intercept? Yes, there is a y-intercept, so we select A. And then they say type it as an integer. They don't want it as an ordered pair. They just want the answer of 0. They just want 0 as the answer. Okay. So there are two specific points that we are going to use here when we graph. Okay. We are going to use the y-intercept when we graph. And we are going to use the vertex when we graph. Our vertex was the point -1, -1. So when you're graphing, when you're using the graphing tool, this is our vertex. And then we have the 0, 0, which is our y-intercept. Okay. This time, when you open up the graphing tool, it will already be a parabola for you, most likely. I think it will just be a parabola. Okay. You don't have to select the parabola. But what you need to make sure you do is you actually plot this point first. You have to plot the vertex first. Plot the vertex first. Then after you plot the vertex, you go over and you plot the y-intercept second. And it will create the parabola for you. And then that's it. You just save it. So this is for the graph. Plot. And look, this is MyMathLab should have a consistent graphing tool. You would think it would have a consistent graphing tool for graphing all quadratics, but it doesn't. If it's more convenient to graph using transformations, it'll use the transformation tool like we used in question 1. When it's more convenient to graph using the vertex and the y-intercept, it will have you graph that way. So this one is a separate way of graphing than the previous one, and there's no way to change it. You just have to work with what the system gives you. All right, we're going to pause here, see if there's any questions specifically about the. All right, so we can actually do a quick sketch of this without the MyMathLab graphing tools. We have a vertex at -1, -1, and our y-intercept is at 0, 0. Our graph will look like this. This is the graph of our parabola. And we have the point -1, -1 is our vertex. So the reason why we want this graph is so that we can answer these questions. Determine the domain and range of the function. We'll do domain in green. Domain is how far left you can go. So how far left can we follow this graph? Well, this graph goes all the way to the left. That's going to be -infinity. How far right does it go? Well, it goes as far right as you want. +infinity. In fact, the domain of every quadratic function is always -infinity to infinity. It's always that. So that's it. That's always what it is. Let's go to the range. We'll do the range in red. How low can we go on this graph? Well, this graph only goes to the y value of -1. And because it actually gets there, we are going to use a bracket on it. So it's going to be bracket -1. And then how high does this go? Well, it goes all the way to infinity. So our range is going to be from -1 to infinity. And the -1 has to have a bracket on it. All right, last two questions. When is our function increasing? All right, what increasing means is this, I think we're okay. As we go to the right, our graph has to be going up. Well, when we first start out, as we go to the right, the graph is going down. So we actually first start out decreasing. Okay, well, when do we decreasing? We're decreasing from the start of the graph, which is -infinity. And then as we go to the right, it's decreasing. As we go to the right, it's decreasing. This one's not the best example possibly, but what we're going to do always, is with increasing and decreasing, you only write X values. When you describe increasing and decreasing, you only use X values. So I'm going to write out what this stands for. And so you write X values and you always use parentheses. Okay, you always use parentheses when talking about increasing, decreasing. So what this means here, I'm going to write it out so that when you're doing your test, you can think about what this means. This means from X equals -infinity to X equals -1, the function is decreasing. And I'm going to write it all out. The function is decreasing. Okay, for increasing, let's choose purple for increasing. As we go to the right, we're going up. Where does that start? That starts at X equals -1, and then it keeps happening. It increases always after that. And what that means is from X equals -1 to X equals infinity, the function is increasing. The function is increasing. Okay, gonna pause here. All right, here we're gonna solve a quadratic inequality. It's gonna be x squared minus 2x plus 5 is less than or equal to 0. So select the correct choice below. If necessary, fill in the box. All right, so perfect. In order to solve a quadratic inequality, we want to graph this thing. We're going to go ahead and graph, because what it means to be less than or equal to 0, that means we're going to be below the x-axis. Okay, so to graph this thing, you need two things to graph. You need the vertex and you need the y-intercept. Okay, so we're going to find the vertex here first. Well, a is going to be 1 because it's the number in front of x squared. B is going to be -2. It's the number in front of x. And then C is 5. And then the x value of the vertex is -b over 2a. So let's plug that in. The x value of the vertex is -b. So we got to be real careful because it's -b and then b is -2 divided by 2 times 1. 2 times 1. And so, well, we need to simplify that. And that's fine. We're going to simplify it right below. It's going to be 2 divided by 2, which is 1. The x value of the vertex is 1. Now, to find the y value of the vertex, you plug 1 back into the function. So that's going to be f of 1, which is going to be equal to 1 squared minus 2 times 1 plus 5, which is equal to 1 squared is 1, -2 times 1 is -2, and then we have plus 5. So this is going to be 1 minus 2 is -1, -1, 5 is 4. All right, so that's true, right? That's true. We didn't make any mistakes. We're fine. The vertex then. The vertex is the point 1, 4. All right, great. So now what's our y-intercept? The y-intercept's super nice. That's when x equals 0. And I know. I need to work on my organization a little bit better. When x is 0. So that if x is 0, then we're going to get f of 0 is equal to, and we're looking right up here, it's going to be 0 squared minus 2 times 0 plus 5. The y-intercept is the point 0, 5. This is our y-intercept. Now, we can get a really good looking graph of our parabola by just graphing. And this is fine. It's not going to be very big, but it doesn't need to be big. Our vertex is the point 1, 1, 2, 3, 4. There's our vertex. And our y-intercept is 0, 5. So 0, 5's right here. And now let's connect them. And then we're going to ask ourselves, when is the graph below the x-axis? When is the graph down here? Do we have any graph down there at all? We do not. So on this one, it's B. There are no solutions. There are no solutions. Okay? There are no solutions because if we're less than or equal to 0, that's below the x-axis. That's below the x-axis. All right, let's pause here. All right, here we're working on number 4. So number 4 asks, and we're looking at this graph, and this graph is pretty small. Just as a nice reminder, on all the graphs, there's a little pop-out button in my math lab. So if it's like small and you're squinting and you can't really tell what's going on, hit that pop-out button, and we're gonna hit the pop-out button here, and well, we're gonna make it look better. We're gonna make it look better. So 0, 0 was a point. It looks like 1, 1, 0 is a point, and 2, 0 is a point, and it looks like this. There we go. All right, so we made it a little bit bigger. We can see it. We want to know, when is f of x greater than 0? Greater than 0 means it's above the x-axis. So it has to be above. It can't be touching because touching is equal to. It has to be above. All right, and so how are we going to do that? Where is it above? Now, every student is a little bit different on how they look at this. Some students, at least in the past, have said, when you fill in the area in between the axis and the graph, it makes it really easy to see where the graph is above. The graph is above from 1, that's not 1 though, that's 0. The graph is above from 0 to 1. And it's above over here as well. That's from 2 to infinity. So we put union 2, infinity. All right. That's when it's above the x-axis. And if that doesn't help you, if you're still struggling looking where it's above and below, please let me know. Again, this is just information from past students. Now, let's answer the other question, and we're just going to come down a little bit here. The other question is, when is f of x less than or equal to 0? Less than or equal to 0. That's a, what did I just put? I put about the x-axis, but really what I meant is above. Oh. Right? When it's less than or equal to 0, that means below the x-axis. Okay, and we're going to show that in red. So red is where I'm going to show that it's below. It's below over here. So from negative infinity all the way to 0, it's below the x-axis. Now, because it's less than or equal to, we are going to use a bracket instead of using a parenthesis. Okay, and then where else is it below? Well, let's fill in below here. It's below union. Now, we're going to use brackets 1 to 2 with brackets on each. Okay, 1 to 2 with brackets on each. And those are our answers. That's how we're going to enter our answers in my math lab. All right, let's pause, resume the recording. This is number 5. This is number 5 on the exam review, right? The final exam review. And we are going to find the zeros. So what does it mean to be a zero? So I'm rewriting the function here just so we can see it's a little bit small. And it says find the real zeros. So to be a zero, it has to be f of x has to be equal to 0. Now, the problem on the final exam, like this, will factor by grouping. So what we're going to do is we're going to factor by grouping. Okay, so we are going to group the first 2 terms together, and we're going to group the last 2 terms together. The first 2 terms have an x squared. So we still have 0 equals, and then we've got x squared. And what's left over is an 11x minus x squared divided by x squared is 1. Now, the other 2 terms, the second 2 terms, they have a 1 in common, which means they have nothing in common. If they have nothing in common, you can always take out a 1. So that's going to become 11x minus 1. Okay. Now, when we look at the whole thing, they both have an 11x minus 1. So on the left side, we still have 0 equals. And then we have an 11x minus 1. And then when that goes away, we are left. I shouldn't have done that. It's not really going away, right? It's coming out in front. What we're left with is an x squared plus 1. We get x squared plus 1. Okay. And then we set each one of these equal to 0. So either 11x minus 1 equals 0 or x squared plus 1 equals 0. After we factor it, we set each factor equal to 0. So then we get add 1, 11x equals 1, divide by 11, x equals 1 over 11. Then we're going to subtract 1, we get x squared equals negative 1. And then when we take the square root, don't forget your plus or minus. But here it doesn't matter because the square root of negative 1, the square root of negative 1 is not real. If it's not real, we don't care about it. The square root of negative 1 is not real, so we don't care about it. The only answer that we are going to select is 1 over 11. So when they ask us the question, find the real zeros, our only answer is x equals 1 divided by 11. That is our only answer. Okay. Now, in the next question says, well, they write these questions out of order, right? Use the real zeros to factor. Well, we already factored it, right? We factored it. Here it is right there. There's the factored form, except don't put the 0 equals. The factored form, it already has the f of x, so you're just going to put 11x minus 1 times x squared plus 1. Okay. All right, let's pause here, see if there's any questions. So one student in the recording or in the session mentioned, this is not what the answer looks like in my math lab. And she is exactly right. Great question. It looks different. I guarantee my math lab will accept this answer right here. In fact, I would find it very unlikely that a student would ever write the answer that my math lab gives. The way that you would get that is you would take the first factor, which is 11x minus 1, and you would choose to factor 11 out. So if you take out an 11, it will become 11 times x minus 1 over 11. Now, it's very strange thing to do to take out that 11 because, why is it strange? It's strange because the second term is not divisible by 11. Can you divide 1 by 11? Yes, you would write that as 1 divided by 11. So this is the answer that I would recommend all students put. It will mark you right. You do not have to have the answer that my math lab is suggesting students use, because that's not an answer that most people would write down. Only a computer would write that answer. All right, great question. We're pausing here, all of this stuff out. So this is number 6 from your final exam review. This is number from the final exam review. All right. And what we're going to do here is for f of x equals the square root of x. So we have f of x equals the square root of x. We should always talk about the domain of f of x first. What we have to worry about is x is in a square root. That means that everything in the square root, which is just x, has to be greater than or equal to 0. So we need x to be greater than or equal to 0. And then g of x. So if we're looking at domain, right? This is your function. This is the function. This is the domain. G of x is equal to 5x plus 6. In g of x, there are no problems. There is no square root and there is no division by x. And now that we know about logarithms, there is no logarithm. So there are no problems with the domain. So negative infinity to infinity is our domain. So we have no problems with the domain of g of x, okay? So it's always good to think about what the domain is ahead of time. Now, in part A, we're going to calculate f of g of x, okay? Now, in order to do that, well, I hate that notation. If I was a student, I would always rewrite the notation as f of g of x, okay? Why would I do that? Because now you can just use substitution. What is g of x? G of x is 5x plus 6. So what we're going to find is f of 5x plus 6. What's that going to be equal to? Well, this means in f, everywhere that there's an x, you replace with f of x. Oop. What am I doing? You replace with the 5x plus 6. All right. So we go up to f. We're looking at f. We see a square root sign, you put a square root sign. We see an x, we're going to write 5x plus 6. So this is your answer for what is f of g of x? It's the square root of 5x plus 6. Now, what's the domain of f of g of x? Well, to figure out the domain, 5x plus 6 has to be greater than or equal to 0. Why does it have to be greater than or equal to 0? Because that 5x plus 6 is in a square root. Anytime you have a number in a square root, it has to be greater than or equal to 0. And then we solve this. We're going to subtract 6 on both sides. It's going to be 5x is greater than or equal to negative 6. And then divide both sides by 5. Here, x has to be greater than or equal to negative 6 over 5. Now, the way that they want the answer is not interval notation. They want it as an inequality. So we leave our answer just like this. Now, x such that, so you have to write the whole thing. You have to write x is greater than or equal to negative 6 over 5. All right, doesn't look great, but hopefully it looks good enough. Let's pause here actually and see if there's any questions. So now we're going to do part B. And what we're going to do here is we are going to just copy paste so that we have it. So part B is going to ask, part B asks it asks g of f of x. Part B says g of f of x. I would always write it as g of f of x. And the reason why I would do that is so that we can use substitution. Instead of f of x, we can write the square root of x. This is going to be g of the square root of x, which is equal to, well, we go to g. I see a 5, we write a 5. We see an x, we write the square root of x. And then we see a plus 6, we write plus 6. This is your answer for part B. So if we go up, it's not worth going up though. That's your answer for part B for g of f of x. Now, what's the domain of this thing? Well, x is in a square root. X is in a square root, so we're going to set everything inside the square root to be greater than or equal to 0. And it's already solved for. X is already by itself. So x is greater than or equal to 0. That is it. This is your domain. Okay. And once again, we could go up and show how to put it, but this is exactly how we're going to put it. The next one is going to be part C, which is f of, well, I'll write it like they write it first. F of x. Well, I prefer the notation f of x. And we can replace that. Replace the inside f of x with what f of x is equal to. So that's going to be f of the square root of x. Well, then we go to f. We see a square root, we write the square root symbol. And then we see an x, we write the square root of x again. So it's going to be the square root of the square root of x. That's how we're going to write it. And then for the domain, x is in a square root. So you set the stuff inside the square root to be greater than or equal to 0. And that's it right there. That's it. All right, let's go to part D. Part D is going to say g of x, which is going to be equal to g of x. And then just substitute. Instead of g of x, we're going to write 5x plus 6. So it's going to be g of 5x plus 6. It's going to be equal to, I see a 5, we write a 5. We see an x, next we see an x, we write 5x plus 6. And then we see a plus 6, so we write plus 6. Now, on this one, we have to simplify because we can. 5 times 5x is 25x. 5 times 6 is 30, so it'll be plus 30 plus 6. So we're going to get 25x plus 36. That is our answer for g of x. Now, what's our domain of this thing? The domain. What is the domain? It is, well, there's no square roots and there's no division by x. Oh, there's no square roots and there's no division by x. So the domain is everything. It's negative infinity to infinity. Now, since we don't write that with inequalities, we're going to go up and we are going to select the answer, the domain. We're going to select, we're going to select the answer that says the domain is all real numbers. Okay, let's pause here. Let's pause. In fact, I'm going to scroll down and then pause. I'm going to scroll down and then pause it down here so that, you know, people with the recording can take good notes. Maybe. All right, let's pause. All right, this one says the function, it's f of x equals x cubed minus 9 is a 1-to-1 function. So we're going to find the inverse. The way to find the inverse, and everyone always teaches a little bit differently. I would always tell the students change the f of x to y and then swap your x and y. So it's going to become x equals y cubed minus 9. And then to solve by itself. So we're going to add 9, we get x plus 9 is equal to y cubed. And to get rid of the cubed, you're going to take the cubed root on both sides. So then we end up with y equals the cubed root of x plus 9. And this is our inverse function. So we could write that as f to the negative 1 of x equals the cubed root of x plus 9. So this is what you would put in the first answer box over here. And this is annoying me a lot, so I'm sorry about this. When I pasted it, or when I'm copying it just from my screen. There we go. Now it annoys me a lot less. Hopefully it wasn't annoying me too much. That's what's going to go in box A. That's what's going to go in box A. Now, we got to find the domain of this thing. The domain. Now, the domain is actually all real numbers. Anytime you have an odd root power, if it's an odd root power, there are no problems with the domain. If it's an even root power, you would have had to set whatever's on the inside to be greater than or equal to 0. Odd root powers are good. Even root powers are not so good. Okay. And I actually really dislike, I really dislike how the order in which my math lab is having you enter these questions. Because how do you find the range? Okay, everybody time out. What I just said is true, but I'm not as mad about the order that they're asking. They're asking for the domain of f. This is f. They're asking for the domain of f. See, they tricked us because they made us find the inverse, and now they're asking us to find the domain of f. It's okay because everything here is all real numbers. But here, there's no root powers. There's no even root powers. And there's no division by x. So there's no problems. If there are no problems, your answer is all real numbers. So our domain and range on these are really boring because the domain is all real numbers. And the range of the function is equal to the domain of the inverse, right? In fact, we should write that out. So if you're looking at the function, this is the regular old function, and then you have the inverse. The domain of the original function is all real numbers. That's the same as the range of the inverse. Why does that inverse look like something weird? That's the inverse. The inverse then is all real numbers. Okay. Now, the range of the function is equal to the domain of the inverse. The domain of the inverse is also all real numbers, which means the range of the original function is all real numbers. Okay. These two are always equal, and these two are always equal. It is a horrible concept to listen to someone say, but if you write it down and you think about it, it's way, 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 way better. Okay, so the range of the original function is all real numbers. Now, what's the domain of the inverse? All real numbers. Everything here was all real numbers, so it was a little bit boring. Now, the next thing we have to do is graph this. Okay, and the purple is the original function. So the original function, we have to graph this using transformations. X cubed looks like this. X cubed minus 9 is shifted down 9. So we go down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is going to be x cubed minus 9. Okay, these graphs are awfully small. They're awfully small. All right, we can eliminate this one. And this one. So we use a different, let's eliminate in red. There's no way those are it. F of x is the purple. Is f of x the purple? Oh crap. F of x is the purple. I think I eliminated one that I shouldn't have. F of x is the purple. No, there's no way f of x is the purple. Our original function was x cubed minus 9. Maybe I'm looking at this wrong? No, x cubed minus 9. So am I crazy? F of x is the purple line. Well, if f of x is the purple line, none of them are the answer. So we have to assume that f of x is, am I crazy? Let me look at the actual thing. All right. Well, we just have to assume that the purple one is not f of x. The blue one has to be f of x. It's got to be C, right? Or is that hitting at -9? It's too hard to tell. Either way, that's what your original function looks like. And then what does our inverse look like? Our inverse looks like x, the cubed root of x. The cubed root of x looks like this. This is the cubed root of x. And then we are shifted to the left 9. So we're going to go left 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then ours is going to look like that. Okay. That's what it'll look like. I mean, these are so small, it's really hard to tell, but it's got to be C. I mean, it's got to be C because C is shifted to the left on the inverse, and then it shifted down in the original. It's just they messed up the colors when my MATHLab printed it out. All right, let's pause here. Let's see if there are any questions, comments, or concerns.